we'll take a look at the very wide range of planning research areas and techniques. There's been quite a lot of work in domain modeling, domain description and domain analysis prior to using these domain descriptions in planners themselves. Then of course the core work in AI planning is been in the search methods, in algorithms for creating plans, searching for plans. People have looked at plan analysis because if you can constrain the types of plan you're interested in through analysis, that can limit the search spaces involved. It could be useful to pause here and to read through this list of areas and techniques. How many have you already heard of? Check out or ask about any acronym you don't know. Continue on when you're ready. Then people concerned with realistic and practical planning problems have often had to deal with the issue of repairing plans when things go wrong or when the circumstances change. A number of people have looked at plan generalization, the reuse of generalized plan fragments. The support of the user involved in planning via suitable user interfaces, advice interfaces, and the ability to generate plans in a mixed initiative fashion between the automated system and a human are important. In recent years, planners have been made available as web services in order that they can be used as a component of larger scale systems. And plans can be used in a range of other areas such as natural language generation, dialogue management, the sharing of plans between humans and so on. Pause again to look at the research areas and techniques listed. So as you can see here, we're dealing with the whole life cycle of plans, right through from creating domain models through making use of those plans in productive situations. The problem is that we need to make sense of all of this. We need to find a way of fitting in the very many techniques that are available now and that will become available through further research and development. What's needed is a more collaborative planning framework. At the outer level, we've got to be able to relate to the humans involved in the planning process, where they can present their objectives, their issues, they can make sense of the situation, they can give multiple options and advice, they can argue about those options, discuss them, outline plans and so on. But then we want detailed planners, search engines, constraint solve analyzers and simulators that can act within that outer framework in an understandable way and use it to provide feasibility checks, detailed constraints and guidance. We want to be able to share processes and information about process products between humans and systems. And we want to look at the current status, the context we're in, the environment we're in order to be sensitive to that. We need a link between informal and unstructured planning and more structured planning and methods for optimization. And that's what we've been trying to do with our IX iPlan work, just an example of how some of this integration is going on in practical AI planning systems. First of all, we base it on an underlying, intelligible, easily communicated, easily extended conceptual model for objectives, processes, procedures and plans, just based on 4 components: a set of issues to be addressed, a set of nodes, which are activities to be included in the plan, a set of constraints which have got to be respected, and a set of annotations on the entities that are involved there. We call that model INCA. Then we want to communicate the dynamic status and presence of the agents involved, their collaborative processes, their process products, and what they're able to do in terms of their capabilities. We want to be sensitive to the current context, so that the presentation of options for action are those which are suitable for the context we're in. And we want to do intelligent activity planning, execution, monitoring, repair, and plan repair, and we do that via the iPlan planner and what we call the IX process panels, which are the user interface element in the IX technology. So IX's aim is a planning, workflow and task messaging catch-all. We designed it in order that it can deal with the wide range of problems that can be addressed in planning and activity management. It's meant to be able to take any requirement to handle an issue, perform an activity, respect a constraint, or note an annotation. So that's the underlying computational model of the IX platform. Then it can deal with these via manual activity, so you can basically just tick items off, for instance, on a checklist. That's a perfectly good way of representing the fact that you've performed an activity in some systems. But also via inbuilt internal capabilities in the system, via external capabilities you know about, or by rerouting or delegating to other panels and agents, which is where communication and collaboration and the models of those other agents comes in. Or we can plan and execute a composite of these capabilities, and you can use the planner inside the system itself to plan that kind of workflow. And then the system receives reports and interprets them to understand the current state it's in and to be able to start to handle that situation and help the user control the situation. And the idea is it can cope with just partial knowledge of the process and organization involved and be able to fit in to an environment where it isn't the only agent that's working on plans and processes within an organization. IX, as we've said before, has been applied to emergency response, and we've used this kind of process panel as a user interface for that sort of task. But it's in a context where there's a lot of other tools, domain editors, links to mapping tools. The planner itself can have a pop-up window which lets you look at the options it's generating and guide them and give them advice and so on. And you can link to messaging and communication tools to the systems. So that concludes this series of presentations on AI planning in context. We've been looking at the context of practical systems, and we've shown you some practical planners in use. We've looked at the context of task assignment and execution, the fact that we're often working with multiple agents, multiple systems and multiple services, and we've looked at the context of plan representation itself, where rich plan representations can be used for many kinds of communication and collaboration in activity and planning situations. And finally, we looked at Planning++ to try to make sense of the wide range of techniques being developed in this field, and looked at a model for bringing some of these techniques together in a productive way.